let's look at an equation involving the square root and see if we can solve it. So solving an equation like this. Well, you know, you can get rid of a square root if you just square it, right? If you take the square root of something and then square it, you come back to that something, the square root's gone. So squaring both sides would be a good idea. But I don't think we should do that right now. If you square both sides like it is, go ahead and work it out on your own. You'll see it gets kind of messy. What would be better is if we had this square root isolated on one side of the equation. That way, it'll be the only thing that gets squared when we square that side of the equation. We won't have this number 1, this plus 1 mucking up the works. So the first step here is to subtract 1 from both sides. All right? So when we do that, what do we get? We get root x plus 5 equals x minus 1. All right, now it's all by itself. We've isolated the radical. All right? So that's the first step in these problems, is to isolate the radical, get it alone on one side. So move the other stuff over. And then we can square both sides, right? So we'll square the left-hand side and square the right-hand side. And let's see what happens. If I said that when we have the square root of something and then we square it, they undo each other. Right? The square root of x plus 5 squared is just x plus 5. So great, the square root is gone. Now what about the right-hand side? Well, we can multiply this out. Now you could do that term by term, but you might remember this formula. A minus b squared is the same thing as a squared minus 2ab plus b squared. Okay. So why don't we just use that formula? So a minus b squared. So it's going to be x squared minus 2 times x times 1. So that's just minus 2x. And then plus 1 squared. So that's just going to be plus 1. All right. And so now what we can do, let's see. Well, we have a polynomial equation. This is an equation with polynomials. And so whenever we solve polynomial equations, what we did is we tried to set one side of the equation equal to 0, and then we factored. So let's do that. Let's collect all the terms on one side of the equation. Let's subtract x from both sides, and let's see what happens. We get 5 equals x squared minus 3x plus 1. Okay. And then we'll subtract 5 from both sides. And so we get 0 equals x squared minus 3x minus 4. Okay, so we got 0 on one side. That was our goal. And now we said that once we get the polynomial equal to 0, we want to factor it. That's using that 0 product property. Because if the product of two things is 0, then one of those two things must be 0. That's how we're going to solve this. So we write this as a product, and that means factor. All right, so we're going to write this as the product of two terms. So we're looking for two factors of -4 that add to -3. Right? Well, that would be -4 and +1. So it factors like this. X minus 4 times x plus 1. And now the 0 product property says that the solutions are going to be the things that make this 0 or this 0, right? So we have x equals 4. And then we also have x equals -1. Okay, so one of those, either of those two things, maybe both of them will be solutions. Now, what you have to be really careful with in problems like this is to check your answers, all right? Because whenever you square both sides of an equation, you might pick up extra solutions. These are called extraneous solutions, all right? So they may be solutions to this part of the problem, but they may not be solutions to the original problem, okay? So we have to check our answers. It's very important that we do this. All right. So we're going to check. Let's check x equals 4. What we're going to do is we're going to go back to the original equation, and we're going to plug in 4 for x and make sure that it works. Okay? So substituting in place of x, I'm going to put a 4. 4 plus 5 root, square root, plus 1. Is that really equal to 4? Well, let's see. 4 plus 5 is 9. So that's the square root of 9. Square root of 9 is 3. 3 plus 1 is 4. So that one checks out. So that is part of our solution. Okay. What else? We have to check this x equals -1. So let's plug that in. So -1 in place of x. Let's see if this works. -1 plus 5 is 4. Square root of 4 is 2. Two plus 1 is 3. Well, that one doesn't work. So this is what we call an extraneous solution. Extraneous solution. That's a solution that arises through the problem-solving process, but that is not actually a solution to the original problem. And so it's not part of the answer. So this is one of the key things we have to keep in mind when we do these problems. Go through and solve it, but then always check your answers at the end. Of course, you should always check your answer in every problem just to be safe, but especially with these, because this can happen very often. Now, it won't always happen. Sometimes both of these will be answers to the original problem, but sometimes they won't. You may even come into a case where neither of them are solutions. You might have a problem where it has no solutions. So all those things are possibilities. So let's see. Same idea. We want to get the radical all by itself on one side of the equation, right? So first order of business, subtract that 8 from both sides. Okay. And now what we want to do is get rid of the cubed root. Well, how do we get rid of cubed roots? Well, we cube both sides. Right, so that will eliminate the cubed root. So we have 4x minus 3 equals, well, let's see, -3 cubed. That's -3 times -3 times -3. So that's -27. Okay, so add 3 to both sides. Divide both sides by 4. And I'm getting x equals -6. And as before, we should check. Just because you get an answer doesn't mean that it's an answer to the original problem. So what I'm going to do is go back to that original problem, what we've started with at the very start. Don't go with any other step in the process. Go back to the very, very original problem. Plug that x equals -6 in. All right, so I'm going to have this. I want to verify that this is true. So the left-hand side should end up equaling the right-hand side. Well, 4 times -6 is -24. And -24 minus 3 is -27. Okay. The cubed root of -27, well, that's -3. And -3 plus 8 is 5. So that checks out. So we can go ahead and say that this is, in fact, our answer. In this case, we only got 1. Notice that sometimes you can get more than one answer, like in the previous problem. Other times you might get 1. Like I said, other times you might get none. always check. Here we have 3 minus root x equals root x minus 3. Okay, so here, I want to isolate the radical on one side. Now I can't do it, I mean, I can get it, it's already isolated so that this radical is all by itself on one side, but the other radical is not. And I can't really manipulate this so that one of them is not by itself, right? So, so I'm just going to have to deal with it like it is. What I would try to do in this situation is make sure that the more complicated radical is all by itself. And that's what we have here. The more complicated radical being root x minus 3. That is all by itself on one side. So I think we can go ahead and square both sides. All right? So we go ahead and square. Well, what happens to the left-hand side? Well, we can use that formula again. Right? If you take the difference and square it, this is the formula. So we'll just plug those things in. So this is going to be 3 squared minus 2 times 3 times root x, so minus 6 root x, plus root x squared. Well, root x squared is just x. So when we square this out, we're going to get 3 squared minus 6 root x plus x. That's what happens. You're just using this, just plugging those things into this formula here. Okay? What happens on the right-hand side? Well, you took the square root, we squared, so we just get this. The square root's gone. Okay, well, I still have a square root in this problem. The square root is still somewhere. So now we isolate it, and we do what we were doing before. So let's see. I can subtract x from both sides. So that kills off the x's. I can subtract 9 from both sides. I can divide both sides by negative 6. All right, and I've isolated the radical, right? It's all by itself. All right, so square root of x equals 2. Now we've isolated the radical, so we do that squaring both sides again. So for the second time, we're going to square both sides. X equals 4. All right, and then we check. I think to save paper, I'm going to check over here. I'm not sure if Office Max is open anymore. It probably isn't. So I have to be a little conservative here. Checking 4. So I'm going to plug 4 in place of x. So we're going to have 3 minus root 4. And just checking, is that the same thing as root 4 minus 3? Well, 3 minus, root 4 is 2. 4 minus 3 is 1. Oh yeah, so that works. That works just fine. So this is in fact our solution, x equals 4.